pleasant day, students. Today, we will be discussing about measures of variability, one of the statistical measures or descriptive measures. As we know that, the statistical measures are employed to describe some important features of the data. In the preceding lecture, the three measures of central locations were introduced. That is the mean, the median, and the mode. We know that a measure of central location allows us to identify the point where most of the data tend to cluster. However, these measure of central locations do not give an adequate descriptions on how the data scatters or deviates away from the mean. So, we need another measure to measure the deviations of the data from the mean, and that is the measures of variability. So when we say a measure of variability, it is a numerical value computed from the given observations. That is, the measures of variability measures how the data spreads or deviates away from the mean. So this measure is often used in comparing two sets of data. The lesser the measure is, the closer the values of the observations from the central value. To illustrate that idea, consider the two sets of data given below. So we have data set A, ito yung data na meron tayo. Data set B, ito naman yung data na meron tayo. So it can be seen that the two sets of data have equal means, which is 80. So yung mean ng data set A is equal to 80 and ganun din sa data set B. However, a closer look at the data set will show that there is a difference in the variability between the two data sets. As you can see here naman in figure 1, right? So mapapansin nyo na ang dataset A has values that are more clustered around the mean. Ang mean natin is 80. While dataset B has values that are more scattered from the mean. Thus, it can be said that the measure of variability for dataset B is larger than the measure of variability for dataset A, right? Hence, we can say that dataset B is more scattered than dataset A. So this example shows that mean values do not reflect the spread or dispersions of data. And to measure the spread or dispersions of data from the mean, we must introduce the measures of variability or measures of dispersion. Now, what are the different measures of dispersion? Some measures of variability that we will be discussed are the range, the variance, the standard deviations, and the coefficient of variation. Among the different measures of variability, the range is the simplest to understand. It is also easy to compute. The range of a set of observations is the difference between the largest and the smallest values in the set. It is denoted by R. That is, R is equal the highest value minus the lowest value. Although the range is a poor measure of variation, particularly if the size of the sample or population is large. It considers only the extreme value and tells us nothing about the distributions of numbers in between. To overcome The disadvantage of the range, we shall consider a measure of variation, namely the variance, that considers the positions of each observations relative to the mean of the set. So given the finite populations observations x sub 1, x sub 2, to x sub big N, the population variance is equal to this one. So for ease of computations, an alternative formula for this one is this one. And it can be verified that the two expressions are equivalent. Also, given the random sample x sub 1, x sub 2 to x sub n, the sample variance is given by this one, and an alternative formula is given by this one. And ganun din, we can verify that this one is just equal to this one. Let's proceed with the properties of the variance. Number one, the variance is always non-negative, and thus it can never be negative. So if may na-compute ka na variance na ang result is negative, may mali sa pag-solve. Number two, a large variance corresponds to a highly dispersed set of values. As I said kanina, na the more na maliit yung values ng variance, the more closer yung mga data sa mean natin. Number three, the variance makes use of all observations. And number four, its unit of measure is the square of the unit of measure of the given set of values. One of the properties of the variance stated that the unit of measurement of variance is the square of the unit of measurement of the observations. That is, if original measurements were in feet, the variance would be expressed in square feet. To get a measure of variations expressed in the same units as the raw data, as was the case for the range, we take the square root of the variance. Such a measure is called the standard deviation. And this is for population standard deviations, and this is for the sample standard deviation. So for the properties of the standard deviation has the same properties as the variance, except the last one, number 4. That is, its unit of measure is the same as that of the observations in a set of data. Now, pwede natin gamitin ang standard deviations to compare variability of two or more sets of data having the same units of measurement with approximately the same mean. Okay? Now, for the case na meron tayong data sets na different ang unit of measurements and magkakaiba rin yung mean ng data sets, ibig sabihin, din natin magamit ang standard deviation to compare the variability of the sets of data, right? Now, to be able to compare the variability of the data sets having different units of measurement, coefficient of variation is used. The coefficient of variations denoted by CV is a measure of relative variation expressed as percentage. It is the ratio of the standard deviations and the mean multiplied by 100%. The formula of coefficient of variations is this one. This is for populations and this is for sample. So here we have the populations of the standard deviations divide the population mean times the 100%. Here, sample standard deviations divide the sample mean times the 100%. Okay? For the property of the coefficient of variations, a desirable property of the coefficient of variations is its being unitless. Thus, it can be used to compare the dispersions of two or more sets of data even if they have different units of measurements. So we are done in discussing the concepts of measures of variability. I-introduce ang measures of variability para ma-measure natin kung gaano kalayo ang mga data values sa mean nito. At meron tayong apat na measures of variability, that is the range, the variance, the standard deviations, and the coefficient of variation. Pinakamadaling intindihin at madaling isolve is range. However, ang range ang pinaka-poor sa apat na measures of variability, particularly if the sample or population is large. And ang always na ginagamit natin to measure the variations of dataset ay ang variance. One thing na problema sa variance, yung unit of measurement nito ay squared ng raw data natin. And to have the same unit of measurement sa raw data, we can use the standard deviations. Magandang gamitin ang standard deviation sa pag-compare ng dispersions of dataset having the same units of measurement with approximately the same means. And for the case na different ang units of measurements, we have the coefficient of variation. Now, magbibigay tayo ng example paano kunin ang range, variance, standard deviations, and coefficient of variation. For example, the grade point average of 20 college seniors selected at random from the graduating class are as follows. So, ito yung data na meron tayo. Find its range, variance, standard deviations, and coefficient of variation. So in here, tuturuan lang kayo paano isolve ang range, variance, standard deviations, and coefficient of variation. So first, hanapin muna natin yung range ng data natin. We have letter A, range, which is equal to highest value minus the lowest value. Ito yung data na mayroong tayo. Ano yung highest value natin? Ang highest value natin is ang 3.8 and ang lowest value natin is ng 1.8. So, ibig sabihin, we have highest value is 3.8 minus the lowest value which is equal to 1.8. So, ang range natin is equal to 2.0. So, ito na yung range natin. So, kukunin na naman natin yung variance nito. So, ang gamitin natin na formula is sample variance dahil sample yung data na mayroon tayo. So, para mas madali, ang gamitin natin na formula is this one. The sample variance is equal to n, the sum of x of I squared, where I is 1 to n, minus the sum of x of I, quantity, squared, over n times n minus 1. So here, kailangan natin alamin kung ano yung n natin, ano yung the sum of x of I squared natin, and the sum of x of I, para ma-compute natin yung sample variance. So here, we know that ang n natin is equal to 20. So kung ika-count mo ito, this is equal to 20. And kunin natin yung the sum of x of I. So here, the sum of x sub I, where I is 1 to n, ang n natin is 20, i-add lang natin itong mga data values natin. So, we have 3.2 plus 1.9 plus 2.7 plus 2.4 plus 2.8 plus 2.9 and hanggang ma-add natin itong lahat na data values. So we have 3.2 plus 1.9 plus 2.7 plus 2.4 plus 2.8 plus hanggang 2.1 plus 2.5 plus 1.9. And this is just equal to 53.3. And next, ang kukunin natin is the sum of x sub I squared. So here, itong data values natin is squared lang tong 3.2 squared plus 1.9 squared plus 2.7 squared plus 2.4 squared plus 2.8 squared hanggang dito 2.3 squared plus 2.1 squared plus 2.5 squared plus 1.9 squared. So we have 3.2 quantity squared plus 1.9 quantity squared plus that hanggang 2.5 squared plus 1.9 squared. And this is just equal to 148.55. So ngayon, meron na tayong n, which is 20. The sum of x sub I is equal to 53.3. The sum of x sub I squared is equal to 148.55. So, pwede natin i-compute yung sample variance, okay? So, now we are ready to compute the sample variance. We have, alam naman natin ng n natin is equal to 20 at na-solve na natin that the sum of x sub I is equal to 53.3 and the sum of x sub I squared is equal to 148.55. So, i-substitute lang natin ito dito sa formula ng sample variance. So, we have 20, ang n natin is 20. The sum of x sub I squared is equal to 148.55 and the sum of x sub I is equal to 53.3 and 20 times 19. So this one is equal to 2,971 and this one is equal to 2,840.89. And 20 times 19 is equal to 380. So 2,971 minus 2,840.89 is equal to 130.11. So divide 380 is equal to 3.3425. So ito na yung variance na meron tayo. Okay? So next, we will compute the standard deviation. Standard deviation is just equal to the square root of variance, and the variance is equal to 0.3425. And the square root of 0.3425 is just equal to 0.5852. So ito na yung standard deviations natin. And lastly, will be the coefficient of variations. The formula of coefficient of variation is equal to standard deviations divided the sample mean times the 100%. So, nakuha na natin yung standard deviation which is equal to 0.5852. So, ang kukunin na lang natin is yung sample mean. So, we know that the formula ng sample mean is just equal to the sum of x sub I over n. And the sum of x sub I is equal to 53.3 and n natin is 20. So, 53.3 divided 20 is just equal to 2.665. Kaya 2.665 ang meron tayo dito. So, 0.5852 divided 2.665 times 100% is just equal to 21.96%. So, ito na yung coefficient of variations natin. So, now we are done discussing the concepts of measures of variability. Pinakita rin paano isolve ang range, variance, standard deviations, and coefficient of variations. So sa next ay tuturuan kayo paano i-compute itong mga measures of variability using Excel, Microsoft Excel. Next, tuturuan kayo how to compute measures of variability using Excel. Sa MW Word text ninyo, naka-indicate doon yung procedures how to compute central tendency and dispersion in Excel, right? So ngayon, para mas maintindihan natin, magbibigay tayo ng example how to solve descriptive statistics using Excel. Sa laptop na mayroon tayong Microsoft Excel, i-click lang yung Excel. And pag-click nyo ng Excel, ito na yung mukha na mayroon tayo. So, we have this one. So, first, i-include ang data. So, dito, naka-include na yung data na mayroon tayo. That is, the GPA of 20 graduating students. So, now, gusto natin kunin descriptive statistics ng data na ito. So, after ninyo ma-include ang data, i-click ang data tab and i-click ang data analysis. So, kung wala ang data analysis dito, i-click ang file, then i-click ang options, then click ang add-ins and select analysis toolpath and click go. Then check analysis toolpath, click OK, and meron na tayong data analysis dito. So now, i-click itong data analysis para ma-compute ang descriptive statistics ng data na ito. So pagka-click ng data analysis, may lalabas na ganito. Just click descriptive statistics and click OK. Input range, ilagay dyan yung data na mayroon tayo. So we have, ito yung data na mayroon tayo. And, ayan. Then, output range, pwede lang dito natin ipa-output yung result na gusto natin kunin. I-check ang summary statistics. And finally, click OK. So, ito na yung result na mayroon tayo. So, dito sa result, we have the mean, which is equal to 2.665. Mayroon tayong standard error, which is equal to 0.130842. Mayroon tayong median na 2.6 and mode na 2.5. Nakalagay din dito yung value ng standard deviations, sample variance, and meron din for cortices, skewness, and range is equal to 2, and the minimum value, which is equal to 1.8, and the maximum value, which is equal to 3.8. And the submissions of all observations, kung i-add itong lahat nito, itong data na meron tayo, that will be equal to 53.3. And the total number of observations is equal to 20. So, sa measures of variability, meron tayong apat na different of measures of variability. That is the range, the sample variance, the standard deviations, and coefficient of variation. So, meron na tayong range, which is this one, and meron tayong variance, which is equal to this one, and meron tayong standard deviation. So, wala dito is yung coefficient of variation. So, pwede rin natin i-compute ang coefficient of variations using Excel as long as alam natin yung formula for coefficient of variation. So, let us say, ito yung coefficient of variations natin. And ito natin ilagay yung formula. We know naman na ang formula for coefficient of variation is equal to standard deviations divide the mean times 100%, right? So, i-click ang standard deviations value, divide the sample mean times 100%. So, we have that one. So, ito na yung coefficient of variation natin, 21.96%. Now we are done in discussing the concepts of measures of variability and computing these measures of variability manually in using Excel. That's all for today. Have a nice day.